The topic today is probability tree diagram, and the question reads, the probability that Joe answers the first question correctly in a test is 2 over 5. The probability that he gets the second one correct if he gets the first one correct is 3 over 5. But if the first one is wrong, the probability that the second is answered correctly is 4 over 5. If the second one is correct, the chance of getting the third one correct is 3 over 5. Otherwise, it is 1 over 5. Draw a tree diagram and use it to find the probability. So this is probability that all the 3 are correct. 2 out of the 3 are correct, and finally at least 2 are correct. We are going to begin by drawing the tree diagram. For the tree diagram, we are going to have the first branch here to represent the first test. So in the first test, we are told the probability that Joe answers the first question correctly is 2 over 5. So if it is correct, then it is 2 over 5. Not correct is 3 over 5. Remember, the sum of these should be 1, that is 5 over 5. So next, we are going to look at the second test. So this represents the second test. So continuing with the question, you're told the probability that he gets the second one correct if he gets the first one correct is 3 over 5. So if he gets the first one correct, then here we now have the second one being correct should be 3 over 5. And that automatically means not being correct is 2 over 5. And then it continues. But if the first one is wrong, the probability that the second is answered correctly is 4 over 5. So if the first one is wrong, then the second one, the probability of getting it correctly should be 4 over 5. And that means that not being correct is 1 over 5. Next, we move to the third one, the third test. So if the second one is correct, the chance of getting the third one correct is 3 over 5. So if the second one is correct, so here we have, if it is correct, then the third one being correct, we are told is 3 over 5. So here we'll have 3 over 5, and therefore not being correct automatically is 2 over 5. Otherwise, it is 1 over 5. That is, if it is not correct in the second test, then the probability of that being, or rather correct in the third test, is 1 over 5. And that means this other one not being correct is therefore 4 over 5. So this is going to repeat even in the other side. So here we have correct being 3 over 5 as we have it up here, and here 2 over 5, and then, or otherwise, we have here 1 over 5 just as we have here, and here 4 over 5 for not being correct. So the sample space is as follows. So the first possibility is all being correct. Second is being correct, and the third one not being correct. The first correct, the second not correct, the third one correct. Here the first correct, the second and the third not correct. Sorry, we missed one here. So here the first not correct, the second correct, and the third not correct. The first not correct, second not correct, third correct, and finally we have all not correct. So with this, we can now answer the question that follows. So we are told to find the probability that all the 3 are correct. So the probability that all the 3 are correct, so we will follow this path here. All the 3 are correct, so that is this. So we are going to have 2 over 5 for this times 3 over 5 times 3 over 5 again, and that should be 18 over 125. For the second part, 2 out of the 3 are correct. So if 2 out of the 3 are correct, so that is, here we have 2 correct, here we have 2 correct, and here also we have 2 being correct. So we have there, and there. So taking the probabilities, so we have the probability of first 2 not, or rather correct, and the last one not correct, plus the probability of this second one, plus the third one, so we have, for the first one, if we follow this path here, we are going to have 2 over 5 times 3 over 5 times 2 over 5 plus 2 over 5 times 2 over 5 times 1 over 5 times 2 over 5 times 1 over 5 plus, finally we have, for this we have this path, 3 over 5 times 4 over 5 times 3 over 5, and this is 12 over 125 plus 4 over 125 plus 36 over 125, and that is 52 over 125. Finally, at least 2 are correct. That simply means the probability of 2 or more being correct, so that is the probability of 2 being correct plus the probability of all correct. So the probability that only 2 are correct we already have here. So for the part 2, which we found to be 52 over 125, and the probability that all of them are correct, we also worked it out right up here. So we have 18 over 125, and when we add this, we should get 70 over 125, and that simplifies to 14 over 25. So that is it for this question. Thank you for watching. See you next time.